All right, fixture accessories. Many fixtures have accessories that can augment the output quality and the color of light. Some of these are no longer commonly used as LED technology has advanced. What is possible with a modern light? But it is still important to be aware of these things because we may encounter them on occasion. Gel and color media is the earliest means of changing the color of light. Actually, let me take that back. It is one of the earliest means. The earliest was they would take like a bottle of wine or a bottle of whiskey and put it in front of the light, and that would filter out the light. But as electric light became more prevalent, we started creating these gelatin-based sheets. So using like gelatin and then dyeing them and then putting that in front of the lights. Now they were great, but they would not last very long. And then around the 70s and into the 80s, we started developing gel into polycarbonate sheets, so plastic sheets that could be colored much more effectively. And that was kind of the history with that. As LEDs become more prevalent, we're seeing less and less gel as time goes on. But it's still useful. Things like the follow spot, we use it there. Color scrollers are an early method of automating color changing in a fixture, and these are devices that could fit onto any fixture. So you put it on the front in the accessory slot, and it has a long ribbon of gels. Some of them you could change the gel order and build a ribbon strip in it, or buy different ones from the manufacturer. But the idea there is it has a little servo motor that would move that strip of gel to whatever color that's desired. It also has a DMX controller built into it. So from your light console, you can select the different colors and kind of create the look based on that. The upshot of that is that you have the ability to make several different colors from one system of lights as opposed to hanging, like a red system or a blue system or a green system all in the same spot. You now have one set of lights that can do all of that, which is useful for theater applications. Barn doors are for wash type fixtures, so think Fresnels and Pars, and they offer a little bit of beam shaping comparable to like your framing shutters and Lecos. They don't work as effectively on LED wash fixtures, as I've said, because you have these multiple arrays and the geometry is all off. Um, uh, some people claim they do. I've never seen them, and I've just never been satisfied with using them on like an array type LED. It will, however, work on any point source, Cobb style LED fixtures. So our Fresnels that we have, they work pretty good on those. But if you've got a flat array with multiple lenses, they're effectively worthless. Top hat, snoot. You see that in the middle? Looks like a wonderful little Monopoly Man top hat. It's not truly a beam shaping device, but it does obscure the face of the fixture and it limits the spill of the field angle. Um, so here's another little picture that we've got right there. So you can see the beam angle, right? Here's your light beam. That's the bulk of what you see. But once you get this diagram's weird. I always thought it was like half the intensity's in the beam angle and half's in the field angle, but it says 10% intensity out there. We're missing 40% of our intensity. I don't know. Whatever. This picture.
Past Ed is an idiot and struggles with simple mathematics, unfortunately. Future Ed here, coming back in time to explain this concept. But I don't have a decent mic right now. Anyway, here's your pool of light. 50% of the output is inside that circle. Light output diminishes gradually from the center of the beam outward. When you reach 50% of the maximum intensity, you know you've found the edge of the beam angle. If you continue your outward journey, at some point the intensity will reach 10% of the original maximum at the middle. This is the edge of the field angle. The main takeaway is even with a very focused beam of light, you will always have some portion that spills over outside that beam. The fact that you can look at the front of a light and see if it's on or off from any angle proves this point. Thank you, and good night.
But the field angle is all of the light that we don't see in the like beam, in that shaft of light, the majority of the light. So if you're looking at a light and it's pointed over left to you and you're not standing in the light, you can still look at the fixture and see light on the fixture face. The snoot or the top hat tends to block that. So if you have a fixture kind of hanging in the view of the audience, you can put that over that, and most of the light output's going to be blocked. The only people that will notice it would be lighting designers, but your dads that are there at the ballet recital are going to be perfectly okay with it. They'll be thrilled that you took the time to make their lives a little bit better. All right, gobos, we've mentioned a couple times, but they are a type of filter that works in LECOs, or ellipsoidal reflectors, and it allows an image to be projected out of the fixture. Simple gobos are made of steel, and the image is cut out of the steel pattern and allows the light to pass through and be focused into the shape of the pattern. So there's the ubiquitous Batman logo, right? Possibly the most famous gobo in all the world. The idea there is that the bat on that logo would be cut out of the steel disc, and then the light would pass through, and that bat image could be projected. The ultimate irony and the most famous gobo in the entire world is that the bat signal light is a lie. You heard it here. The bat signal light is almost always mounted to this big, like, searchlight, the big beams of light that you have outside the gala to attract everybody there. And they put the bat symbol over it and think, like, oh, yeah, we put that on the cloud. It's the Batman. It's like, no, it doesn't work that way. The geometry's all wrong. The physics of it, that you have to have the ellipsoidal reflector funneling it through the aperture to get the effect of projection, and it doesn't work on a like effectively either a parabolic or a spherical reflector with a high intensity discharge lamp. It's not going to happen. Batman is a lie, and it's being perpetuated by the movie industry. But I'm here to tell you, if you're going to use the bat signal, you got to use an ellipsoidal reflector spotlight. It's the only way. But going along with that, you can see our own bat signal, the Florida Tech logo down there at the bottom. You can make these into custom things. You see them a ton in weddings. It's like Mr. and Mrs. blah, 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 hearts and flowers, and you have a little steel disc to remember your big day for the rest of your lives. But it can be super complex if you start using glass. So dichroic glass, you can add like an image onto it. You can add color. It is a little bit more creative than just using the steel by itself. Donuts are delicious, but it's also a gel frame size piece of metal with the hole cut in the middle there that you can see next to Homer's donut. And it helps sharpen the image of a gobo and a LECO. It accomplishes this by reducing the little reflections that are aberrant and kind of coming out of different angles outside of that beam angle. So it's going to reduce the overall output of your light, but the light that does pass through it is more concentrated in that shape of that pattern. Another cool accessory is a drop-in iris. We talked about the follow spot has this iris, but you can also get one for a LECO. It can be used to narrow the beam at the cost of reduced intensity because of absorption. But in a pinch, you can put it into a LECO or a source 4 or an ellipsoidal and turn it into a follow spot on a stick, which is a very common use for those devices. Lastly, on this slide, the twofer or the triple tap that we see more often. The twofer is more common with your older incandescent lights because you have a 20 amp circuit that has 2400 watts, right? Because we know if you have 20 amps at 120, you get 2400 watts, right? My electrical engineers. Your source 4, even let's say even your 1000 watt old as dirt Fresnel lamp is going to only take less than half of that circuit. So you're wasting, 1400 watts. Now, best practices say we shouldn't load any particular circuit to more consistently 80% of the total load. So like a spike over here and there is not going to blow anything up, but you shouldn't load it down to 2400 watts and call it a day because it's just going to tax everything and it could eventually blow the breaker. But even then, 2000 watt fixtures still 2000. That's still well below the threshold of the 2400 watts. So twofers were used to kind of give you a little bit more flexibility. Granted, you're not going to have the same control because both lights will come on with the dimmer, just the same, as any other, but it would give you more intensity per circuit. The concept that we use the 3 first for with the LED lighting uses less wattage. You can put more on a 20 amp circuit than you could with tungsten. So the triple taps are used in our circumstances to help break out power for different applications there. Care should be taken not to overload a circuit, because a lot of times those little power taps that we use have 10 amp breakers in them or 12 amp breakers, and they will pop without warning.